All right, let's dive in. Every single time you click a link, type in a web address, or stream something online, there's this secret conversation happening just out of sight. Today, we're going to pull back the curtain on HTTP. It's the unseen language that literally powers our entire online world. So, what's really being said in that secret chat? It really does feel like magic, doesn't it? You type something into your browser, you hit enter, and poof, a website just appears. But what's actually happening under the hood? How is that conversation between your computer and that website even structured? Let's break it down. Well, at its heart, it's actually a super simple conversation. You've got two main players. On one side, there's the client, that's the asker, which is just your web browser. And on the other side, you've got the server, that's the provider, the big computer that's hosting the website. Every single thing you do online is just a request from the client and a response from the server. That's it. Okay, so here's one of the absolute core ideas of HTTP. It's stateless. And what that means is the server basically has amnesia. It has no memory of who you are or what you asked for a second ago. Every single request you send is treated as a brand new event. Now you're probably thinking, wait a minute, websites do remember me. And you're right. That's where things like cookies come in. They're like little reminders your browser holds onto so that with each request, it can say, hey server, it's me again. You're basically creating this illusion of a stateful experience, all on top of a protocol that by its very nature forgets everything. This simple design is what makes the web so incredibly fast and able to scale to billions of users. All right, so if every single message has to carry its own weight and be completely self-contained, what's actually packed inside one of these messages? Let's pop the hood and take a look at a typical request your browser sends out. Okay, the very first line of any request, it's the big one. It's the most important part. It tells the server three crucial things. What you want to do, that's the method. Where you want to do it, that's the URL, or the specific resource. And finally, what version of the language you're speaking, that's the protocol version. So you'll see something that looks exactly like this, get/profile HTTP/1.1. Let's break that down. Get is the method, and it's basically saying, hey server, I want to read or retrieve something. /profile is the specific thing we want to get, and HTTP/1.1 is just us telling the server which dialect of HTTP we're using. No guesswork here, super direct, super clear. Right after that main instruction, the client tacks on a bunch of headers. The best way to think of these are like digital sticky notes attached to the request. They give the server extra context, like what kind of browser you're using or what language you prefer. Honestly, the best way to picture this is to think about sending a package in the mail. The headers are all the info written on the outside of the box, the shipping address, the return address, instructions like this side up or fragile. The actual stuff you're sending, the body, is packed safely inside the box. And that brings up a really key point. Not every request even has a body. If you're just asking for a web page, you don't need to send any data. But when you fill out a contact form or you upload a picture, that data travels inside the body of the request. And there's always a blank line separating it from the headers, just to keep things organized. Okay, so the server gets the request, does its thing, and then it fires back a response. And the very first thing it sends is a status code. I mean, we've all run into the dreaded 404 not found, right? But the one you're always hoping for, the big win, is 200. It just means, okay, everything worked perfectly. And you'll see the response looks a lot like the request. It's got its own headers, which might tell your browser how long to cache the page for. And then, of course, a body. The body is the good stuff. That's the actual HTML code for the web page, or the image file, or whatever it was you asked for in the first place. So remember that method we talked about, that first word in the request? Let's circle back to that for a sec, because these methods are essentially the action verbs of the internet. They give every single request a very clear purpose. For the most part, the common methods are exactly what you think. Get is just for reading data. Give me that page. Post is for creating something new, like when you submit a form and create a new account. Put or patch is for updating info that's already there, like changing your profile picture. And delete, well, yeah, that one's pretty obvious, right? This structure makes every single action on the web predictable and clear. So, okay, we've got this super powerful and clear language. But you know what they say? With great power comes, well, the need for some serious security. So let's look at a security system that's built right into HTTP itself. It's called CORS. Think about this for a second, because it's a little scary. Let's say you've got your email open in one browser tab, and you accidentally open a malicious website in another tab. What stops that bad website from just making a request to your email service and stealing all your data? Well, the answer is something called the same origin policy.
By default, your browser is like a super strict bouncer at a club. It blocks any code running on one website, say evil.com, from trying to get data from a different website, like your email.com. It's a fundamental security rule.
But, sometimes you actually want different websites to talk to each other. It's necessary. And that is where Chorus comes in. It stands for Cross-Origin Resource Sharing, and it's basically a system that uses those HTTP headers we talked about to let a server grant permission. It can say, you know what, it's okay for that specific website over there to ask me for data. For anything a bit more complicated, the browser does this really clever thing called a pre-flight check. First, it sends a tiny little options request, basically asking for permission. It's like, hey server, I'm from example.com. Would it be okay if I sent you a delete request later? The server then replies back with its list of rules, and only if the rules match up does the browser go ahead and send the actual request with the data. It's like a quick, polite, and totally secure handshake before the real conversation begins. Okay, so we've taken apart the messages, we've looked at the action verbs, we've even checked out the security. So why does this all matter? Why has this specific structure been the invisible backbone of the web for decades?
The genius of HTTP is really in its design. First, it's standardized. It's a universal language that any computer anywhere in the world can speak. It's also simple, which makes it reliable and easy to work with. The intent is always crystal clear. But maybe most importantly, it's extensible. We can add new headers and new features to support brand new technologies, all without having to tear down and rebuild the entire internet.
It's incredible, really. This simple, elegant, stateless protocol of requests and responses, it built the entire digital world we live and breathe in every single day. From the simplest blog posts to the most complex applications, it's all powered by HTTP. And that just leaves us with one big question. As our world gets even more connected, what will the language of the next web need to be?